Model Test 2, Listening Section.
The listening section tests your ability to understand spoken English that is typical of interactions and academic speech on college campuses. During the test, you will listen to conversations, lectures, and discussions, and you will answer questions about them. This is the short format for the listening section. On the short format, you will listen to 2 conversations, 2 lectures, and 2 discussions. After each listening passage, you will answer 5 to 6 questions about it. You will hear each passage one time. You may take notes while you listen, but notes are not graded. You may use your notes to answer the questions. Choose the best answer for multiple-choice questions. Follow the directions on the page or on the screen for computer-assisted questions. Click on Next and then on OK to go on to the next question. You cannot return to previous questions. The listening section is divided into sets. Each set includes 1 conversation, 1 lecture, and 1 discussion. You will have 10 minutes to answer all of the questions for each set. You will have 20 minutes to answer all of the questions on the short format. A clock on the screen will show you how much time you have to complete your answers for the section. The clock does not count the time you are listening to the conversations, lectures, and discussions.
Listening 1, Professor's Office.
Listen to part of a conversation between a student and a professor.
Professor James, do you have a minute?
Sure, come on in. What can I do for you?
Well, I did pretty well on the midterm.
You sure did. One of the best grades, as I recall.
But I missed a question, and I'd appreciate it if you could help me understand what I did wrong. I have the test right here, and I just can't figure it out.
Okay, fire away.
It's question 7, the one on biotic provinces and biomes.
Oh, that one. Quite a few people missed it. I was thinking that we should go over it again in class. But anyway, let's look at your answer.
Thanks. Here's the thing. I said that a biotic province was a region with similar life, but with boundaries that prevent plants and animals from spreading to other regions. So an animal, for example, a mammal, it may have a genetic ancestor in common with another mammal. But a biome's a similar environment, an ecosystem really, like a desert or a tropical rainforest. So in the case of a biome, well, the similar climate causes the plants and animals to evolve, to adapt to the climate, and that's why they look alike.
That's good. Very good, as far as you went. But there's a second part to the question. Look, right here. Include an explanation of convergent and divergent evolution. So I was looking for a more complete answer. Next time, be sure to include both parts of a question, when there are 2 parts, like this one. Do you know how to explain convergent and divergent evolution?
I think so. Isn't it like when a group of plants or animals, when they're separated by mountains or a large body of water, then subpopulations evolve from a common ancestor and they have similar characteristics, but their development diverges because of the separation. So that's why we call it divergent evolution.
Right. Even when the habitat's similar, if they're separated, then they diverge. How about convergent evolution then?
Well, that would be a situation where a similar environment, a habitat, it may cause plants and animals to evolve in order to adapt to the conditions. So a species that isn't really related can evolve with similar characteristics because it can look like a species in another geographic region because of adaptation. And that would be convergent evolution?
Right again. So temperature and rainfall, proximity to water, latitude and longitude all combine to determine the climate. And if we know the climate of an area, then we can actually predict what kind of life will inhabit it.
Okay. And I really did know that. I just didn't put it down. To tell the truth, I didn't see the second part, not until you pointed it out to me.
That's what I thought. Well, Jerry, it's a good idea to double-check all the questions on a test, not just my test, any test, to make sure you've answered each part of the question completely. Otherwise, you won't get full credit.
I see that. Well, live and learn.
Jerry, you're one of my best students.
Thanks. I really like biology. In fact, I'm thinking of majoring in it.
Good. That means you'll be in some of my upper-level classes.
And I'll be watching out for those 2-part questions on your exams.
And all the rest of your exams. I'll be honest with you, my questions usually have two parts, so the students will have an insight into the grading system, and a lot of professors do that. In an essay question, it's difficult to know what to include and how much to write. Just read the question carefully and be sure to include all the parts. There may be 3 or 4 in some essay questions. This is the way that the professor helps you organize your answer. I'm giving my students a hint about what I'm looking for by including several parts to the question, but if you miss one of the parts, then it lowers your score.
That makes sense. I think I was just trying to finish within the time limit and I didn't read as carefully as I should have. On the final, I'll spend more time reading the questions before I start to answer them.
Good plan.
1. Why does the man go to see his professor? Two. Listen again to part of the conversation, and then answer the following question.
Thanks. Here's the thing. I said that a biotic province was a region with similar life, but with boundaries that prevent plants and animals from spreading to other regions.
Why does the man say this?
Thanks. Here's the thing.
Three. What did the man do wrong? Four. According to the student, what is divergent evolution? Five. What will Jerry probably do on the next test?
Listening to Art History Class.
Listen to part of a lecture in an art history class.
We know that the Chinese had been aware of basic photographic principles as early as the 5th century BC, and Leonardo da Vinci experimented with a darkroom in the 1500s. But it was a number of discoveries in chemistry during the 18th century that accelerated the development of modern photography. The discovery that silver salts were light-sensitive led to experimentation with images of light on a surface that had been coated with silver. Often, glass was used in the early images. But the problem was that these images were ephemeral, fading after only a short time. Some of the chemists who worked with them called them fairy pictures and considered them that they were only momentary creations, that they'd disappear. Okay, how to fix the image permanently was one of the most important challenges of the early photographer chemists. In France, in about 1820, Nicéphore Niepce discovered a method for fixing the image after a long exposure time, probably 8 hours. So, although his work was considered interesting, it was largely dismissed as impractical. Nevertheless, one of his associates, Louis Daguerre, managed to find a way to reduce the exposure time to less than 20 minutes. So the story goes, in 1835, Daguerre was experimenting with some exposed plates, and he put a couple of them into his chemical cupboard. So a few days later, he opened the cupboard, and to his surprise, the latent images on the plates had developed. At first he couldn't figure out why, but eventually he concluded that this must have occurred as a result of mercury vapor from a broken thermometer that was also enclosed in the cupboard. Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates. The process itself was somewhat complicated. First, he exposed copper plates to iodine, which released fumes of light-sensitive silver iodide. These copper plates were used to capture the image, and by the way, they had to be used almost immediately after their exposure to the iodine. So the image on the plate was then exposed to light for 10 to 20 minutes. The plate was developed over mercury heated to about 75 degrees centigrade, which caused the mercury to amalgamate with the silver. Now here's the ingenious part. He then fixed the image in a warm solution of common salt, but later he began using sodium sulfite. Anyway, after he rinsed the plate in hot distilled water, a white image was left permanently on the plate, and the quality was really quite amazing. But the process had its limitations. First, the images couldn't be reproduced, so each one was a unique piece, and that greatly increased the cost of photography. Second, the image was reversed, so the subjects would actually see themselves as though they were looking in a mirror, although in the case of portraits, the fact that people were accustomed to seeing themselves in a mirror made this problem less urgent than some of the others. Nevertheless, some photographers did point their cameras at a mirrored reflection of the image that they wanted to capture so that the reflection would be reversed and a true image could be produced. Okay. Third, the chemicals and the fumes that they released were highly toxic, so photography was a very dangerous occupation. Fourth, the surface of the image was extremely fragile and had to be protected, often under glass, so they didn't disintegrate from handling. The beautiful cases that were made to hold the early images became popular not only for aesthetic purposes, but also for very practical reasons. And finally, although the exposure time had been radically reduced, it was still inconveniently long, at 20 minutes, especially for portraits, since people would have to sit still in the sun for that length of time. Elaborate headrests were constructed to keep the subjects from moving so that the image wouldn't be ruined, and many people simply didn't want to endure the discomfort. But by the mid-1800s, improvements in chemistry and optics had resolved most of these issues. Bromide as well as iodine sensitized the plates, and some photographers were even using chlorine in an effort to decrease exposure time. The portrait lens was also improved by reducing the size of the opening and limiting the amount of light that could enter, so the exposure time was about 20 seconds instead of 20 minutes. And negative film had been introduced in in England, and negatives permitted the production of multiple copies from a single image. So, photography was on its way to becoming a popular profession and pastime.
6. What is the main topic of this lecture? Seven. According to the professor, what two limitations were noted in Daguerre's process for developing and fixing latent images? Eight. Listen again to part of the lecture, and then answer the following question.
At first he couldn't figure out why, but eventually he concluded that this must have occurred as a result of mercury vapor from a broken thermometer that was also enclosed in the cupboard. Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates.
Why does the professor say this?
Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates.
Nine. What substance was first used to fix the images? Ten. What can we assume about photographers in the 1800s? In what order does the professor explain photographic principles?